For Math 1 for section 4.5 on linear inequalities. Please make sure to take notes on this in your interactive notebook, and I don't know which page, but it should be the next page right after 4.4 where we taped in those glued in those notes. So go to the next right hand page, the next odd page of your notebook. So this is on linear inequalities, and this is going to relate to 4.6. So 4.5 and 4.6 go together very well, and you're going to need to make sure that you get this one first. So let's talk about our first inequality symbol is the greater than, and this one below is the less than. And one way that I remember that is because the less than kind of looks like an L. Now if you have this little thing underneath, that means greater than or equal to or less than or equal to. It means if it's equal to, it's included in the set. So greater than or equal to, and less than or equal to. Okay, so let's just practice using these symbols. So true or false. So take a minute, look at these four inequality statements and decide if they're true or false. So, alright, hopefully you've had a minute to think about it. You could pause if you need to think about it a little bit more. So we have 3 is less than or equal to negative 10. Okay, if you think about the number line, alright, you have 0, and then you have all the negatives over here. So negative 10 is over here, and 3, the positives are over here. Positives, no matter how big the positive, it's always bigger than a negative. Negatives, think of them as small. So this is a small number compared to this, which is a large number. Okay, so positives are always greater than negatives. So this is false. Similarly, we have over here, negative 5 is less than 0. Yes, that is true. All negatives are less than 0. Okay, let's look at this one over here. We have 0 is greater than 0. Now, if you have the same number on both sides, you need to make sure that you have the equal to, which we don't in this case. So, this is false. Alright, now let's look over here. This one we need to simplify. We have to use the order of operations, so we're going to multiply first. That gives us negative 6. And then add 4. Okay, so negative 6 plus 4 is negative 2. So then the question is negative 2 greater than or equal to negative 8? Alright, when you're dealing with two negative numbers, the smaller the negative number, the bigger it is. Basically, numbers that are on the right of another number on the number line are greater than. So negative 2, which would be right here, and negative 8, which would be right here, negative 2 is more to the right, so it's greater. So this is true. Okay, so let's talk about linear inequalities. A linear inequality is the set of all points that are less than or greater than and possibly equal to a given line. So you're not just talking about the points on the line, right? When we graphed y equals mx plus b, the solution was what we graphed were all the points on the line. So now we're talking about all the points that are less than or greater than that line. So you get a lot more. So like greater than that line would look like this. Less than that line would look like this. So you get a whole section. In fact, it's an infinite number of points. And so how we graph it, like I'm doing, is shading it. So this is an example. The y is less than mx plus b. Or it could be y is greater than mx plus b. Or it could be less than or equal to, or greater than or equal to. But you don't have an equal sign. The equal sign goes away and you get one of these symbols. So a solution of a linear inequality is a point that when you plug it in, it gives you a true statement. So that's what we're going to do to test if a point is a solution. We plug it in and see if it is a true statement. If it is, it's a solution. So which of the following points are solutions of the inequality? So we have y is greater than negative 2x plus 5. So I have 4 points here. Remember, our point is x comma y. We're going to plug them in one at a time. So here my y is 1. Then my x is 3. Now because this is not an equal sign, I don't need the numbers to be the same on both sides. I just need the inequality to be true. Okay, so I have, if I simplify this, this is negative 6 plus 5. Negative 6 plus 5 is negative 1. So is 1 greater than negative 1? Is this true? Yes, this is true. So this is a solution of this line. And we'll look at what that means visually in a minute. So this one is a yes. Let's try 0, 6. So x and y, so 6 is greater than negative 2 times 0 plus 5. That gives me 6 on the left, and this is 0, so it just goes away, so I have 5. Is 6 greater than 5? Yes, that's true. Okay, let's try negative 2, 9. So let me put a y here for yes. Negative 2, 9. So that gives me 9 is greater than negative 2 times negative 2 plus 5. Negative 2 times negative 2 gives me 4 plus 5, which is 9. So I have 9 is greater than 9. Now this is not an equal to. There's no equal to symbol here. So this is false. Alright, let's try another one. 1, 4. So let me put it in here. 1, 4. So 4 is greater than negative 2 times 1 plus 5. That's negative 2 plus 5, which is 3. So we have 4 is greater than 3. That's another true point. Okay, I think I'm going to do one more because I want to show you at least one more that's not true. So I'm going to clear this. Okay, and then I'm going to find one more point that's not true just to show you. So, oh wait, this was a yes. Yes, true, same thing. Okay, so let's do 5, comma, let's see, what are we going to get? Let's do 5, negative, that's a little too big. 5, negative 7. Okay, so y is negative 7 greater than negative 2 times 5 plus 5. So this is negative 10 plus 5, which is negative 5. So we're looking at negative 7, and we're wondering, is that greater than negative 5? And the answer is no. Remember, the bigger the negative number, the smaller it is. Okay, so this is another no. Okay, so now I'm going to show you what the graph looks like. I'm not going to tell you how to graph it just yet. But we'll look at the graph and then we'll see sort of how those points compare. Okay, so this is the graph. There's some components to this, right? First of all, you do have a line. You do have y equals mx plus b on this graph somewhere. It's this boundary right here. So like the y-intercept is 5, you see a point here. Our slope is negative 2 over 1, so we're going down 2 over 1, down 2 over 1, okay? So you get this line. Now notice it's dotted. We'll go into why that's true in a minute. And we also have shading. All of this area is shading. So let's go back to those points that we had. Okay, some of them were solutions, some of them were not. So let's graph them on here and compare this to the graph. So let's see, we had 3, 1 was a yes. Here's 3, 1. This was a yes. We had 0, 6, which was a yes. 0, 6 would be right here. Some of these points I could see were not going to fit, but that's okay. We had negative 2, 9, which was a no. Negative 2, 9. Yeah, we're not going to fit that on here, but it's way... Oh, negative 2, 9. Here's negative 2, 9. Somewhere up here was a no. We also had 1, 4 was a yes. That's a yes. That's a yes. What else? We had 5, negative 7. Again, we can't see that one on here. Okay, so let's try some more points that are actually on here. Let's pick like 0, 2. That's this point right here. So let's test that one. So y is 2, x is 0. Okay, so that's a 0, goes away. We get 2 is greater than 5. Is that true or false? That's false. 2 is not greater than 5. Okay, so this is a no. Let's try negative 2, negative 2, 3. Okay, that's this point right here. Plug in the y. Plug in the x. Okay, we get 3 is greater than 4 plus 5. Because this is going to be a positive 4. That's 3 is greater than 9. That's false. Okay, so what I want you to see here is all of the points not shaded, they're not in the shaded region, are no's. They're false points. Now over here, you see this point right here, this point right here, this point right here. These were, this is the shaded region. And in this case, they are yeses. They are true points. Okay, now what about if a point is on the line? Like this point right here. This point is 2, 1. So let's test that one. Let's clear a little space here. So 2, 1. 1 greater than negative 2 times 2 plus 5. Okay, well negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. So I have 1 is greater than 1. Because we don't have the equal to, that makes this false. And that is why it's dotted. Because there are no answers on the line. Because we don't have the equal to sign there. If the equal to sign was there, then that would become true. In that case, we make it solid. Okay, so now here are the steps to graph a linear inequality. There's two major steps. The first one is you're going to graph the line. If it is not in slope-intercept form, put it into slope-intercept form first. That's y equals mx plus b, because that's the easiest way to graph a line. Okay? Then you have to determine to make it dotted or solid. So if it is greater than or less than without the equal to sign, make the line dotted. If it is greater than or equal to or less than or equal to, make the line solid. This is because the points on the line are only solutions if it is equal to. Alright, after we have a line, we have to shade. We shade one side of the line. There are two ways to determine which side to shade. Method 1, if it is in slope-intercept form, which is the mx plus b, then you shade above if you have a greater than or equal to, because greater than goes with above. Now, the y has to be on the left. It can't be mx plus b and then the y, okay? It can't work that way. And then if it's below, you shade below if it's less than or equal to. That's method 1. Method 2, you test a point. Okay, you don't want to pick a point on the line, so that test a point that is not on the line. 0, 0 is a good one. If it is true, shade the side where the point is. If it is false, shade the other side. The shading represents all of the solutions. Okay, so let's do one completely from the beginning. An example here. We have 3x minus 2y is less than or equal to 6. First, I'm going to graph the line. So you're graphing the line as if it's an equals, but it's not. Okay? First thing I'm going to do is I'm going to put it into slope-intercept form. So I'm going to solve for y. So I'm going to subtract this 3x from both sides. That leaves me with negative 2y is less than or equal to. Remember to put the x term in front of the number. So negative 3x plus 6. Divide by negative 2 to everything. Now you have to remember you're dealing with an inequality here. So when you divide an inequality or multiply an inequality by a negative, this sign has to switch. Okay, so that's going to make this y is greater than or equal to. Then negative 3 over negative 2 is 3 over 2. The negatives cancel. Times x minus 3. So now we're just going to graph this line. Because it's got an equal to, that means we're going to make it solid. So then we're going to plug in negative, or y-intercept is negative 3. 1, 2, 3, okay. And our slope is 3 over 2. So we're going to go up 3, right 2. 1, 2, 3, right 2. We can do it a couple more times. 1, 2, 3, right 2. 1, 2, 3, right 2. We can also go down 3, left 2. Down 3, left 2. Same line. So because this is a solid line, we're just going to draw the line like normal. Okay, so go through all those points. Okay, so now we have to determine the shading. Okay, because this is an inequality, it's different. So for a shading, there's two ways that we can do it. I'm going to show you both methods. So method 1 is we look at the graph in slope-intercept form. So it's y is greater than or equal to 3 halves x minus 3. So then greater than means we shade above. So above the line would be this direction. So all of this gets shaded. You don't have to do anything, you just scribble. Just fill it all in. Okay, that's method 1. Okay, method 2, so I'm going to do it again, is you pick a point. And the point cannot be a point on the line. It has to be either above or below. And the one that is easy to pick is 0, 0. 0, 0 is the origin right here. So we want to know, is it true? If it's true, we would shade that side. If it's false, then you shade the other side. So we have to test it. So we plug it in. Whoops. So plugging in 0, 0, you can plug it into the original or you can plug it into this one. It doesn't matter. I'm going to plug it into this one. So 0 is greater than or equal to 3 halves times 0 minus 3. Now the reason this is convenient is because multiplying by 0 just makes things go away. So now we have 0 is greater than or equal to negative 3. Is 0 bigger than a negative? Yes, it is. Okay, so since it's true, we shade on that side. Okay, and we're done. I'm going to show you one more example. Recall that if you have y equals a number, it's a horizontal line with a 0 slope. And if you have x equals a number, it's a vertical line with an undefined slope. Okay, so if I were to graph x equals 2, it's x equals, so that makes it vertical, so up and down. But then I'm just going to start thinking about the inequality portion of this because it's less than. This is going to be dotted because it doesn't have the equal to. So I'm going to find x, here's my x-axis, find 2, it's right here. So I'm going to go up and down and make a dotted, straight up and down line along x equals 2. Now to shade it, just got to think about it for a second. Think of a number less than 2. Well, 1, 0, negatives. So all you got to do is shade on the left. If it was greater than, it'd be on the right. And then we're done.